Hey class, this video is still section 8.1, ratios and proportions, although now we're going to be using ratios to model and solve problems. Okay, so here's a word problem. A picture frame ABCD has a perimeter of 60 centimeters. The ratio of side AB to BC is 3:2. Find the length and width of the picture frame. So your first step to solving any type of word problem is to draw yourself a picture. A, B, C, D. And you know the perimeter is 60 centimeters, so that means all four sides added up have to be 60 centimeters. It also tells you that the ratio AB to BC is 3:2, so it tells you that AB is longer. What we're going to do is use this to set up a new ratio, 3x compared to 2x. Since we don't know what the lengths actually are, but we can figure out what they are based on this ratio. Now, if this is a rectangular picture frame, I know that opposite sides are the same, so this has to be 3x, and AD also has to be 2x. Now I know what all four sides are in terms of x, and I know the perimeter. So we're going to be adding up all four sides and set that equal to your perimeter of 60. So we've got 60 equals 10 x's. Divide both sides by 10. 6 is equal to x. Now, I could use that value to find the length and the width by plugging it back into here. 18 and then 12. Those are the dimensions for this picture frame. Okay, and it gives you centimeters, so you want to add on your units. Okay, let's try number 2. It tells you that the measures of angles in a triangle are in a ratio of 1 to 2 to 3. Find the measure of each angle. So pause the video for a second, draw a diagram, see if you can get some ideas going. Okay, hopefully you have a triangle drawn with 3 angles labeled J, K, and L. And just like the last example, I'm going to use my ratio to compare values of x. So 1x to 2x to 3x. And those are going to directly correspond with the order of the angles that were given to us in the diagram. So J is going to have a value of 1x. K is going to have a value of 2x, and L is going to have a value of 3x. Now, all 3 angles inside of a triangle add up to something special. You should remember from the last unit that the sum of interior angles of a triangle equals 180. So I'm going to add up all of these to equal 180 degrees. And now we're going to solve for x. So 6x equals 180. X equals 30. But that doesn't tell me the measure of each angle. I now have to plug that back in. So angle J is 30 degrees. Angle K, 60 degrees. And angle L, 90 degrees. You could always check this by adding up 30 plus 90 plus 60, and it should always be 180 degrees. Number 3 is really similar, except now we have an isosceles triangle. So you should try to make your diagram look isosceles, with SU being the same as SN. Okay, now it says that the ratio comparing SU to UN is 3 to 2. So again, 3x to 2x. SU is 3x, UN is 2x. And if these two sides are the same, SN has to also be 3x. See if you could pause the video to set up an equation if you know that the perimeter is 56 inches. Okay, so you should have something like this. The perimeter of any shape is all the sides added up equal to that perimeter. So that's how I got my first equation. Then I'm just solving. I got x equals 7. Now you want to plug that value in, find the side length of each side of the triangle. And again, you can always check your answer by comparing the perimeter that you got now that you've plugged in the value of x, if I add all three of these, it should come out to be 56 inches. Okay, this next part is about proportions. So we learned a lot about ratios. What's a proportion? A proportion just describes a relationship between two ratios that are equivalent. So it looks like an equation, but really it represents two equivalent ratios. Okay? The purpose of a proportion is to figure out the missing part of a ratio. So in example number 1, I need to find x. And the way that I'm going to do that is by cross multiplying. You may remember doing something similar to this in Algebra 1. And then you just divide by 5. 19.2. And you could always check by plugging back into x and seeing if that ratio is really equal to 3 to 5. Okay? Let's jump down to question number 3. Again, you're always going to set up your cross multiplying. But if you have an expression, you want to make sure that you put that in parentheses. Now I've got a number outside of a set of parentheses, which means that I have to distribute that value. Okay, now you can solve for x. Go ahead and finish solving that and then resume the video to see if you got the same value that I did. You should get that x is equal to 7, and then you just want to go back and check by plugging that in. So 7 minus 1 is 6. 7 plus 2 is 9. If I compare 6 to 2 and 9 to 3, those are equivalent, so it checks out. Let's try example number 5. Again, 5 times 20. Now I have 4x times x. Anytime you multiply a variable times itself, you will always get that variable squared. So in this case, 4x squared. Okay? 5 times 20 is 100. Now, according to your order of operations, we need to get rid of that 4 before we can do the square root, since that 4 is not being squared. Now I can take the square root of both sides, just like you do in Pythagorean theorem. Most of you will say that the answer is 5. Well, could also be negative 5. If I plug in negative 5 here, it will also create two equal ratios. So the way that we represent our answer is with a plus or minus. And the reason for that is when you take the square root of something, there's a possibility that it can be negative, because a negative number squared is always positive as well. Okay, let's try number 6. It's very similar. 6 times 4 equals 2x times 3x. Multiply those coefficients first to get 6. X times x is x squared. Always divide the 6 first until you have a variable squared by itself. Then you can do your square root. And it will always be plus or minus your value that you get. Okay? Questions 7 and 8 have multiple answers, so I'll give you some time to play around with them, and then when you're ready you can resume the video to see some possibilities, but keep in mind if your answer is not on the sheet, it might still be correct. So if you're curious, you can come check in with me and I'll let you know if you got it. Here are a few examples for questions 7 and 8 for you to check for accuracy. I hope that this video helped you understand how to use ratios to model and solve word problems, and how to solve basic proportions.